everyone, and welcome to Activity 36. Today we are going to start talking about representing our linear systems of equations as matrices. So if you think about a system of equations, like you've been seeing since Algebra 1 time, we can take information from this and arrange it into matrices. So there's three parts to a matrix equation. The first part, A, is the coefficient matrix. So you take the coefficients of your variables, in this case x and y, and you organize them into a matrix. The first equation in one row, second equation's coefficients in another. And then we take the variable matrix, x, and that's where you are going to stack your variables, in this case, x over y. Finally, that is going to end up equaling our constant matrix, so that piece that's on the right-hand side of the equation, those will be the pieces in your constant matrix. So that, again, makes up our matrix equation, A times x, so coefficient matrix times variable matrix equals that constant matrix. So again, we see how this is working out, where we multiply A times x and it will equal B. Now, very important to note that this variable matrix is a column matrix, because when we eventually multiply this out, if you want to think of it that way, we would have a 2 by 2 and a 2 by 1, so that this multiplication can actually happen. Had we organized this data so that we had the constant matrix times a row matrix, then we would have a 2 by 2 and a 1 by 2. This wouldn't be possible. So very important that you list that as a column matrix so that this multiplication can happen. And if it did, you'd notice it just results back in the original. So we have a couple examples here about organizing that data into the correct matrix. Now, one thing to note, you want to make sure you set this up so that you have variables on one side, constants on the other. So if we look at this one here, for instance, this negative 7q should be moved back to this other side, so that we really have 6p plus 7q equals negative 3, so that we can make sure we line up our matrices correctly. So we have our coefficient matrix. We have 1, 9, 6, and 7 as those coefficients. And then our variable matrix, we have variables p and q. And then last but not least, that's going to equal our constant matrix, in this case 13 and negative 3. And again, we can label these. We know we have the coefficient matrix, the variable coming next, and last, that constant matrix that it equals. In example 2, we have a 3-variable system. So again, we want to make sure that we have everything lined up so that it's x, y, and z all on the left-hand side. Now notice in the second part of this system that we have 1x, 0 y's, and negative 3 z's, and then equals 7. And we want to be careful of that, because when we order our matrix, we want to make sure that we include a 0 as the entry for the y in that particular equation. Similarly, in the last one, if we add over, notice there are 0 x's, 8 y's. We need to move over that 3z to the left-hand side so that we have that constant by itself. So really, that's the equation reordered that we're going to want to use. And again, we can start this off. We will use the coefficients. So 4, negative 8, 2, 1, 0, negative 3, and then 0, 8, 3 as our last row. Variables this time are x, y, and z, and they are equaling 9, 7, and 11. And again, we have the coefficient, the variable, and the constant matrix. Now, we also want to be able to set up a systems of equations when necessary and represent it then as a matrix. So if we read through this, we have a nutritionalist who is creating a meal plan with 2 types of food. Food A has 10 grams of protein and 5 grams of fat. Food B has 6 grams of protein and 8 grams of fat. And if we want to have a total of 70 grams of protein, 50 grams of fat, what are our servings of food A and food B that are necessary? So we're going to choose two variables. I'm going to choose A and B to represent the servings of food A, and then B to represent the servings of food B. And if I know I want 70 grams of protein total, I can use the protein from A, the protein from B, and together 10 grams from A plus 6 grams from B times however many servings should equal that 70. And then similarly for the fat, we would take the 8 and, the 5, and we want a total of 50 grams, so we would have 5 grams times however many servings of A, 8 grams from B, and 50 total grams of fat in our meal. So we have our system, like we saw up above, that we can now represent using our matrices. So we have our coefficient matrix, we have our variable matrix, and we have that constant matrix this time. Right, and again, a lot of times what we want to do is be able to label, the constant is actually this one. We have our coefficient coming first, and then the variable in the middle. Last one is for you to try. We will work more with these in class and move on to eventually how we actually solve this in the next lesson. Thanks, everyone.